guys ready for some blast? Are you ready to blast off? Yeah, it's going to be a blast or not. Okay, in one of your mini tabs, please go to Workspaces, BV-BRC Workshop, and then go into Blast. And let's look at the README doc, mainly because I want to get this sequence for this particular gene. And really, this gene isn't of any particular interest. There's nothing earth-shattering that I know of about this gene. I chose it because it was present in Buchnera, which are the isolates from aphids, and not in Ricea. So I'm using this purely for demonstration purposes to show you how you can do the different selections in what we provide for BLAST so that you can look at things. And it's also for the cautionary tale, right? Like I tell you, oh, it says that you don't have a gene in this protein family. Don't publish upon that until you do a BLAST and verify that it's actually missing, especially if it's a really important gene, because the reviewer is going to do that. So you don't want to be caught out on that. So let's copy. Bob would be able to take that gene identifier and submit it to memory and then put it in the global search. I cannot. So I'm going to go in, I put it in the global search, and then I say proteins, and then I say any exact term. If you want to test why I do exactly those things, I welcome you to try all of these. However, from experience, I don't want to, so I'm choosing any exact term. So click on that. But I'm not going to stand in the way of your exploration. And it may be that we can't see any exploration ourselves if this doesn't go a little bit faster. Oh, what an important protein that we need to see. So this is the flagellar M-marine protein FLIF. And I remember why I chose this because in the protein family sorter, I could see that there was a whole group of genes that the Buchnera had that the Ricea didn't have. And those were flagellar genes, which gives some mobility to a bacterium, help it build the flagella. And it's an indication that Ricea said, no, I don't need that anymore because I'm happy here in my little louse host. We could go to the feature here, or we could scroll down and get the FASTA sequence, but let's just open this so we have this feature so that you can, in the future, get the nucleotide sequence or the amino acid sequence. So let's first start with BLAST-N, because let's pretend that we want to look to see if it's available and broken across contigs and it just wasn't called on a gene. So where it says NA sequence, click the view. And there's this long gene here. Actually, it's not that long. I'm going to copy and paste it. And then in a different tab, I'm going to go into services and I'm going to click on BLAST. Now, here are all the flavors of BLAST that you can do. The ones that are nucleotide based are here on this side of the panel. The ones that are protein based are here on the other side of the panel. So I'm going to enter my sequence here. Note that you could upload a FASTA file or you could select a feature group. All of those things are for your particular pleasure. Let me point out that you can choose to look at contigs or genes when you have BLAST-N. We're using BLAST-N right now. And then an important thing is the database source. We allow you to filter in on all different kinds of things here. If you want to look at the bacterial reference and representative genomes, you can put those in, or the viral ones. If you click on genome list, you could gradually add genomes of interest to you if you didn't create a genome group. If you have a genome group or a feature group or a taxa or within a FASTA file that you have. So here's another place in the resource where you can look at data from outside, both as the source here, because I could cut and paste that into this text box, Or I could direct it and say, here, I found this gene, and this is my assembled contigs over here that I don't want to annotate in BV-BRC, but I want to see if this gene is present in them. So I could direct it there. Let's do genome group. I'm going to look at this pruned ANL group. Those were the Ricea genomes that I believe did not have this gene. So I'm going to direct it to the output folder that I've created for this workshop for myself. And I'm going to tell me what the flavor is. Last in the, I'm going to say Buchnera gene, the Ricea. Now at this point, I can submit it. If I leave it here with view results, then I can't submit any other jobs until this page is finished. It will reload the page when it's done and show you that. I just want to submit another job pretty quickly. So I'm going to check off view results, and I'm going to go ahead and submit this job. And then it says it's submitting it. And then it says it's been successfully submitted. Check the jobs page. So once I have this here, then I can play with it, because you know what? I'm always questioning, always doubting. If it came back with negative results, how do I know that BLAST is actually working on this website? It could be that it's going to mislead me. So I want to do a controlled experiment where I'm going against the positive to make sure that it's working. That was a Buchnera gene. Let me go back and look at that. So now instead of this pruned ANL group, I want to go within a taxon. So I'm just showing you different ways, different flavors you can do. And I'm manipulating it within the page so I don't have to cut and paste multiple times. And then I start writing Buchnera. Oh, rats. There are two genera here. I forgot about this. So I'm not going to do it this way. Generally, when you name something like a genus, it's supposed to be unique. Well, the bacteria people have precedence on this name, and the plant people, their taxonomic group allowed them to name Buchnera a plant genus, as I recall. I believe it's a plant genera, which is in total violation of everything I believe to be true. And that's why we see this ridiculous problem here. But here I can fix it. Oh, I'm going to just go to the species. Aphidicola. Okay. All right. So now this is last in Buchnera, the Buchnera aphidicola. Okay. So I'm going to submit this one. And while we're submitting jobs, because I can see they haven't completed yet, let's go ahead and go over to the jobs page and look and see what's happening here. It looks like this one completed. Okay. What do we expect to see here? I expect it to say there were no results. Let us pray that it says that. Okay, so this is all the BLAST output files, but remember, always look up here and see if it's directing you to look here. Here's all the stuff on it. I never, ever, ever, ever look at that stuff, but I will click up here to the view and give it a few minutes. It already says there are no results found, but let me warn you that this page sometimes takes a few seconds to load. So don't get misled and think that it will load right away. And so it says, when I took this Buchnera gene that I saw in the heat map, remember yesterday when we were in the heat map and I showed you how you could collect a series of genes out of that and download it? This was one of those. But because we're trying to move things along at a clip, I didn't go over that. So let's see if my other job is done. And this is just to test if it's true. So I click on this and I click on view, and then I click on the blue eyeball that's staring out at me from the upper right. You notice how briefly it said no results found and then overwrote the table. And so this is telling me, here's the query ID. Oh, here's this same bug. This is a bug that we know about, but it hasn't been fixed yet, that shows us the genus and the contig that it's on. Remember that part in The Wizard of Oz where he says, ignore the man behind the curtain, Dorothy? So please ignore this stuff because it's a bug. When it's actually working, it would say Buchnera epiphyticola USDA, and then it would give you the contig, which is, whatever the one is there to show you what that is. It says that it had 100% identity, 100% query coverage, and then you see it's got 0.63% subject coverage. And your first thought is what? Well, that's bad. The subject coverage is really bad, except remember, you're taking a gene, you're blasting it against a contig. It's going to show you what percent of that contig has the gene. So actually, then you say, once you think about it, you say, no, that's good. It's all good. This is what I want to see. The query length, which is the length of the gene, the subject length, which is the length of the contig, the score, and the e-value. What is missing from this that you see when you do BLAST at NCBI? The alignment, right? If you click here and open that, then you will see the alignment with all the values. Why did I do this Buchnera versus Buchnera? I did it to prove to myself that BLAST at BV-BRC is working, so I feel confident in that. Let's just quickly go back to our feature page and let's get an amino acid sequence. Okay, yes, it's the same gene. Yes, very boring, but I just wanted to show you a different flavor in this. So we can go into tools and services, BLAST, and I'll put that in. And then right away, it's going to think I'm thinking nucleotide unless I tell it. So I can say, and see, and it's already, before I could even click on it, it tells me I've made a mistake. But if I click on that, then it says, oh, okay, I understand, things are all right. So we could leave it against the reference and representative genomes. This is going to take a long time if we do it. Let's choose something a little bit better. Let's try genome list, and I'll try Ricea. And remember, we don't expect this to work. And so I could do some of my private genomes here. I would rather do this private genome because it's not the clone population. It tells me something, although not that much, but. And then I could say, oh, I want to look at these ones. I don't want to see any more private genomes. Did you see how I did that? I clicked on the funnel icon and then I click off my genomes. And then I get rid of that and I say Ricea. And wait a second while it tries to find that. Oh, here's that chimpanzee genome. So let's just choose those two. And granted, this is going to be boring, right? Because we already know it doesn't exist. But I just wanted to show you, this is mainly to demonstrate how you can add different things here. The output folder, the output name, BLAST P, Buchnera B2 Ricea. And I'm going to click off view results. And I didn't mention before that if you click on advanced options, you can specify the number of hits and the e-value threshold. So I didn't mention that before. Remember, the smaller numbers mean the more specific hits. Let's just put it at 10. We don't expect anything to be here, but maybe there's something that's even remotely similar in these two things. This would be like the absolutely worst blast hit that I could think of, but I'm putting it in anyhow, submitting that job. And then because I am a doubting Thomas, I'm going to click on genome group and I'll start typing Buchnera. Oh, there's the Buchnera ANL group. And then I'll say BLAST P Buchnera B Buchnera. And actually, I want it to be more specific because I don't want to get all the Buchnera junk. And I will submit that. So we've got those selected. They're both running, but it's going to be fast. I sense it. Up, see there? See how fast BLAST is? So I can click on that. I can click on view. And actually, I don't know what I'm going to see here because remember, I set the stringency way back. So maybe some, oh, and it was able to find some genes. But when you look at this one, so this is from that chimpanzee genome. Remember, this is a flagellar protein, and the closest thing it could find in here was this, which is of this length. There's the length and the alignment. The percent identity is 36, which is not so great. The query coverage, meaning of the amino acid sequence I brought in, 7% of that was covered. And the subject coverage, remember, this is BLAST-P, right? So here we're looking at an amino acid sequence, not an entire contig thing. So it's only finding similarity over 16% of that with a score and a almost embarrassing e-value. But I asked for that. When you make choices, you have to deal with the consequences, and this is my consequence.
Yeah, good question. Can we download the alignment? I tried the download button, but it's downloading the table as, but not.
Not yet. But now that they know you want it, they are going to embrace it. And I imagine that a ticket is being created right now for some lucky developer, and he'll be tagged in it. And he'll open that thinking, oh, Christmas has come early for me. And then he will be told to work on that, and it will be labeled as an enhancement. The question was, can I get an alignment from BLAST? At this point, I can't imagine that you would want the alignment that I showed you. But if you did, you could submit that same thing to the alignment tool that I think is going to be demonstrated next. And that way you could download that alignment of your dreams. Let's make sure BLAST-P is working. I always do this because I never trust anything. No results found. Oh, and there they are. And if I open them up, oh, beautiful, beautiful. Oh, but let me show you another thing. I wonder if I can do that from here. Another thing you can do, which I neglected to tell you, I can launch a multiple sequence alignment with multiples of these. This is different from the tool that somebody is about to show you. This is one that you can do on the fly that you don't need to submit to the service. And I believe that Bob showed it to you yesterday, but even from the BLAST, I can download those. Gives me a gene tree to the left. Across the top is web logo that tells you what the amino acids are below there. And if they're really big, like this E, it shows you that there are more of those. And you can scroll across that. And I don't know what this, I've never clicked on this download. Oh, do you see that in second row? You can get the MSA text, FAST-AO, but not the alignment itself. It gives you everything that you, except the thing you actually wanted. So it's just trying to tease you, and I apologize for that. I'm assuming it would not give me the muscle output, but let's see. What would I open this in? A text edit? Let's open it in mail. Just kidding. Oh yeah, it's giving that. Okay, so it is giving you what you want. So there's always a way. That's what I found in all of these things. I've been learning how to manipulate tools just the way I want. One of the women in the group asked me, she's been growing some viruses in chicken cells, and she wanted to know, should she use taxonomic classification to try to find that? And then I noted too that under organisms and eukaryotic hosts, that we have Gallus, which is the chicken genome. So I suggested that she go to FASTQ utilities, align Gallus. And so this is a eukaryotic genome, and she could put her, that was grown in chicken cells. So she can map that using the align function of the FASTQ utilities pipeline, pull up the unmapped reads, and then she has a better chance at getting a better quality genome because it's throwing out all that messy eukaryotic DNA that nobody wants to see, nobody in this room wants to see. So there's always a way to manipulate things the way you want. And sometimes I use the snip tool for things that it wasn't designed for, just because it gives me some of the things I want.